Hello, welcome to IT 468 Week 9 highlights. In this video, we'll look at the last stage of the database development lifecycle, the ongoing database management and maintenance. Once your database is in place, it doesn't mean you can rest assured. In fact, setting up a database is only a start. If you want to ensure your data will remain reliable, up-to-date, and secure, then you have to establish a database process and policy, and to make sure only authorized users will make authorized activities at authorized time. And basically speaking, there are three major database administration functions, namely concurrency control, security, backup, and recovery. And we'll walk through each of them briefly in this video. To start with, concurrency control ensures that one user's work will not inappropriately affect another one's work. And without adequate concurrency control, when multiple users attempt to update the same data about the same time, and you'll encounter serious problems such as lost update or inconsistent read, as we'll illustrate using the following example. Now suppose a married couple with a joint bank account, and it's likely they may go to the ATM machine to make a withdrawal in different places, but at about the same time. And as shown here in this picture, it's possible the wife withdrawal will actually overwrite or destroy the John here, the husband's request, and that's what we call lost update, because they're trying to process and update the balance data about the same time. And similarly, if John trying to read the balance data which has been only processed by a portion of a transaction from the wife, and that's inconsistent read or incorrect read. In order to prevent such concurrency problems, and the solution is resource locking. Very kind of like intuitively, that simply means if you want to process some data, make some update or change, we're going to lock that particular data set so no one else can touch that while you are working on that. And basically there are two types of locks, either implicit or explicit, depending on who issues the lock. If the locks are issued explicitly by the programmers, the database developers, and that's what we call explicit. Otherwise, if it's automatically issued by the DBMS, that's implicit. And in reality, in practice, implicit by DBMS are much more common than explicit, for the reason it's more efficient, it's easier to control, it's easy to make modification as well. And in fact, using the same example here to illustrate, if we have implemented locking strategy appropriately, and now when the wife comes in trying to make a withdrawal request, we'll put her into waiting queue until the resource has been released after the John, the husband's transaction has been completed, and so that the lost update problem will be prevented. And similarly, the inconsistent read problem will be avoided as well. And in reality, in fact, all you need to do as a developer is to declare the lock characteristics to mark the transaction boundaries. And such transaction boundaries are essential information the DBMS need to know in order to issue, to replace, or to actually even change the level or types of locks automatically. And in other words, implicit locks are much more commonly used in reality. And to give you an example here quickly, to mark the transaction boundary means you can use the keywords. Here we're using generic SQL code. Simply can be applied to different DBMS platforms here. If you mark the boundary using begin, end, commit, etc. keywords, and then the DBMS actually knows where and when to issue or release the locks as needed. And as a kind of quick hint for this week's assignment regarding concurrency control, remember in this week's assignment, we're using the James River Jewelry Company example. And the first question given 3 transactions at the particular company, which one needs to be made atomic? In other words, which one needs to mark boundaries to make sure it's will be considered as one single unit? So all steps, all processes, all kind of like steps within a transaction needs to be completed, or none of them should be. That's what I mean by atomic. And in other words, which one needs you to actually mark the boundary to ensure it's a particular unit. And the very smart and quick hint here is, in fact, you can simply count how many tables need to be updated within that transaction. If it's more than 2, then definitely you will need to mark the boundary to make it atomic. Otherwise, it's possible one table may get updated, but the other one may not, and therefore leading to inconsistent read or lost update. Using the first one for example, acceptance transaction. As we read through the transaction description, it means that at James River Jewelry Company, if a new kind of item is received, we need to first insert a new row into the owner table. So owner table needs to be updated. And in addition, new record also needs to be inserted into item table and jewelry item table accordingly as well. So if you don't mark boundary, if you don't make acceptance transaction atomic, and that means chances are it's possible you maybe succeed updating owner table, but not with item or jewelry item table. So there's inconsistency now. And in other words, if we mark a boundary and making the acceptance transaction to be atomic, and that means both owner table and item table together with the jewelry item table will be updated. Otherwise, none of them should be. So that's what I mean by atomic. And in other words, in brief, simply count how many tables needs to be updated in a transaction. If it's more than one table, then you definitely need to make it atomic by marking the boundaries so that the DBMS needs to how to issue and how to release logs as necessary. So we use the first transaction for illustration, and you can apply the same analysis to price adjustment and sales transaction here. Simply count how many tables need to be updated. If more than 2, you definitely need to mark the boundary to include all the table update statements within that single transaction, atomic, to be atomic, so that either all of them be updated correctly or none of them should be updated. So that's what I mean by atomic, marking boundary so that the DBMS can issue implicit logs. And this is some quick hint for your week 9 assignments. Question number 1. Now let's move on with our illustration and explanation about the second major function here, security. You want to ensure that only authorized user can perform authorized actions at authorized time. And in fact, it involves 2 layers of security measures. The first one we call authentication, meaning that you give them an account, a valid account, in order to log onto your system. That's authentication. Give them username, password. And the second step, the second layer, is what we call authorization, meaning that for those authenticated users, you want to specify very detailed permission, processing rights to each of them to making sure they can only touch on, they can only update or change or delete the items within your database for their job kind of requirements. That's authorization. And this one shows a generic security model which can be applied to any given business. And for all the objects, meaning including all the tables, triggers, procedures, forms, reports, and you can give different permission. Could be only read only, or maybe able to update or delete, and so on and so forth. Give those different permissions on different objects to different users or different roles. And in practice, it's recommended, it's preferred to assign permission to roles or groups other than to individual users to be more efficient. For example, if you want to change some permission rights for accountants, for all the people within accounting group, then you only need to make that change for that role. and then all the users associated with that role will be given the updated permission rights accordingly to be more efficient. So this is a generic security model, and using your textbook example, this one shows a particular assignment of a processing rights to 3 different groups of people within a particular given company, including assistants, management, system administrators, and all the different tables within that particular database. Now I'm highlighting this particular table to give you idea, to give you some hints, again for this week assignment, question number 2 for James River Jewelry Company. In fact, the question there also involves 3 different groups of people to be the administrative assistants, management, system administrator. So this one really gives you a very good example to kind of like guide you through the question number 2 in this week assignment. And make sure the table column will list all the tables within the jewelry, the James River Jewelry Company database. And then you can actually leave the other 3 groups of people there, but you need to analyze in details about what kind of processing rights you need to assign to them on different tables. And as a smart hint, keep it minimal, which means, for example, if the assistant only need to read and change some, let's say the customer table, then do not assign some insertion or deletion the other rights more than necessary. Don't do that. So keep it minimal as long as they need to do their job, and that's all. So don't give them more than what they need for their job duties. That's what we call the minimum rule for security, kind of like a consideration. Again, so for your question number 2 of this week assignment, you can use this table as a template, as a kind of like a guidance, give you some guidance. And for all the tables for within the James River Jewelry Company database, you're going to analyze what the job duties, what the job transaction requirements for the 3 different groups of people to do their job, and therefore you'll be able to assign a different processing rights to them on different tables. So that's some quick hints for question number 2 of this week assignment. And also for your deliverable purpose, the last deliverable for the Gun and Glory project, and you will need to encrypt your database as a part of your security measures. And as a very quick hint here, in order to encrypt an access database, you need to open, be careful, you can find the encryption kind of tool very easily under the database tools. However, there's one warning sign here. You cannot do that directly if you open a database already. In fact, you will be given a warning message, and you have to open your database in a particular mode in order to encrypt or decrypt. And I show it here quickly. So go to the access, trying to click the file open, and then find your database which you're trying to encrypt. And the key part here is here. So the key point here is, don't open it normally, open it exclusively. So you need to choose the drop-down button for open, and then change the default to normal open to open exclusively in order to encrypt or decrypt. So that's a particular hint. After you open the database exclusively, you'll be able to set password to for encryption purpose. And be careful when you submit your deliverable, make sure you include your password if I cannot open your database. And then obviously there's no way for me to grade your last deliverable for your team project. So that's a quick hint for your deliverable 4. Now the last major function we're going to talk about will be database backup and recovery. Remember, computer systems fail and hardware may break, and software programs have bugs, and people make mistakes. So it's always necessary, it's really actually very, very important to always back up your database and also have recovery strategies in place whenever you need to get your database back to work as soon as possible. There are 2 general techniques for recovery, either reprocessing or rollback and roll forward. In fact, reprocessing sounds very kind of simple and intuitive, simply reprocess all the lost transactions. But in reality, it may not be feasible for a very simple reason. I'll give you an example. Suppose you have a perfect memory about what happened yesterday, and I'm able to maybe roll back the clock and put you back to yesterday. And then, are you sure you can actually repeat everything that happened yesterday? Well, be careful. This time, you may insert a floppy disk, let's say 3 seconds, maybe faster than the first time. And you may respond to an email prompt message, maybe 5 seconds slower than the first time. And such small and minor differences may result in different execution order of multiple transactions and eventually leading to different results as well. And not to mention, reprocessing is also very time consuming, and you may never get the time to reprocess all the lost transactions because you have new transaction coming in all the time. So for all those reasons, in fact, in reality, we normally use rollback and roll forward strategies for database recovery. And I give you a very simple and quick illustration of both of them. Now, roll forward. When to choose roll forward or backward, it actually depends on how severe, how horrible the database failure is. If the crash is really serious and you lost your database, you totally lost the database, so it's damaged and you can no longer working, it's no longer working, and then you're going to do roll forward. So first, you're going to look into your backup, save, find your most recent saved copy of your database, and then check the after images in your log file, log file. And after image records all the new values of those changes committed by those valid transactions. And then you're going to reapply those changes and to your most recent saved copy to getting back to a workable stage of database. Now be careful about the difference between roll forward and reprocessing. Reprocessing means you're trying to reprocess all the transaction per se. Roll forward does not need to reprocess the transaction. It simply reapply the changes made by those transactions. It's much quicker. Think about, for instance, one transaction may involve over 1,000 lines of programming code and steps and actions, and in fact, they only make one simple change to one single cell within a particular table is possible. So reprocessing will take forever to do that, but roll forward only needs to rewrite that particular new change committed by that transaction. So that's the difference, and it's possible and feasible with roll forward. Again, to choose roll forward, that means the database failure is very severe and very horrible. You lost your database, so you have to find your saved copy, then reapply the changes as recorded in the log file, which we call the after image, new values of those changes, and to get your database to a workable stage. And the keyword here is reapply the change. That's roll forward. Now, in comparison with rollback, the failure is not so severe, it's not so horrible. Your database has not been lost, so you still have your database running. The problem is there's some wrong or partial or incorrect changes you want to remove, and that's when we do rollback. So we're going to start with our current database. You no need to find a saved copy because your database is still running. And then in order to undo, the keyword here is undo. In order to undo, to remove the partial or incorrect changes, you simply again look into your log file. That's why keeping a log file of all the transactions is really important for doing database recovery. So we check the log file for before image, which means the old values recorded before each of those committed transactions. And then you're going to actually copy those old value to replace the current one, to undo, to back out the partial change. And therefore, you're getting your database to a clean stage again. And again, in the log file, in fact, your textbook gives a sample kind of log file examples as well. So I recommend that you take a look so you have a better idea of what I'm talking about. In the log file, we record every step of each transaction committed to the database, and in each kind of like a particular log transaction, a log record there, we not only record the before image, the old value before the change, but also after image, the new value after the particular change. So which means depending on whether you want to roll back or roll forward, so you redo or undo by applying either after or before images. So that's a very quick illustration about roll back and roll forward to give you a basic idea to start with. And for some quick hints again for your question number 3 of this week assignment. And first, I want you to think about whether that current backup kind of strategy for James River Company is sufficient or not. Think about saving, making backup copy only once a month. Is that kind of like frequent enough? And also, saving the backup CD at a manager's house, that definitely sounds not a very smart idea. Think about how if the manager gets unsatisfied with his or her job. Okay, think about the possible damage to your valuable data set for the company. And also, if some kind of crash happens, if there's a database failure and reprocessing, do you think that's a feasible strategy at James River Company? Or maybe you should consider or research on the rollback and roll forward strategy instead. So these some quick hints for question number 3 of this week assignment. Again, based on the third major function here regarding database administration. And that's pretty much the video highlights for this week. And also, we're almost there for completing this quarter. So hopefully you have gained some basic ideas about the database design, analysis, development, implementation, ongoing management, and also for the SQL processing for information retrieval. So have fun working with your database examples and also in your future work as well. And hopefully to talk to you later.